Another identity on page 460, number 20. Okay, again, the general strategies tell me that I want to work with the more complicated, move to the less complicated. So again, I'm going to work on the left-hand side because there's fractions there, it's more complicated. I'm going to follow the strategy on page 456 where it says combine fractions by putting them over a common denominator. And I'm also going to just try to get things worked out here to sines and cosines. So I've got cosines, I've got fractions, I need to combine them. So let's give them a common denominator. So let me first take this. This needs the factor 1 plus cosine of x. And it would be the same as this if this had a 1 minus cosine of x. So multiplying top and bottom of these fractions by what I want. Okay, that gives me 1 plus cosine x over this 1 minus cosine x times 1 plus cosine x. The other side, the other half of this looks like this. Now they have a common denominator. 1 plus 1 minus, 1 plus 1 minus. All right, and I can put these together. Now wait a second. When I put these together, this whole thing right here ends up just being 1 minus cosine squared x. And I'm thinking that's Pythagorean. So when I rewrite this, I'm going to put it all over, first of all together, this plus this, so this plus this, over this whole thing, which is really just 1 minus cosine squared x. Alright, I don't think I've done too many steps. I probably should have done a couple more steps just to show how this is this, and then show how these things can be combined together. But I've got a positive cosine x, a negative cosine x. Those cancel out. So the top of my fraction is just 2, and the bottom of my fraction is 1 minus cosine squared x. Now, my Pythagorean identities tell me, if you remember, Pythagorean identities, all right, if I were to subtract cosine squared x from both sides, I should have just sine squared x. So here in this problem, 1 minus cosine squared x, that's just equal to sine squared x. So this denominator turns into sine squared x. All right. So I've gotten somewhere, I've gotten pretty far, but I'm not done yet. Remember, this equals 2 cosecant squared x. So I'm just going to work on one side at a time. I've got my left side pretty well taken care of, but my right side I think I want to change because cosecant is 1 over sine. So let me put it in the denominator as sine, and now it's very clear that this is indeed an identity that can be proven. All right, one more video I'm going to make, video number 29, and you will be on your own, 1 through 32. The tough problems, 52 through 57, are going to be fair game on the quiz, so make sure you look at those as well. But there's another one. Good luck.